Hey everyone, Nitesh this side. So let's start with the question. So the question is contiguous array. So you are given in binary array nums, return the maximum length of a contiguous subarray with an equal number of 0 and 1. So you have to return an subarray from an array which have the equal number of ones and equal number of 0, and that length of the subarray should be maximum. Okay, so if we took it with an example, so let's take 0 1 0. Okay, so for this, if you can see 0 1 0, I can take this one subarray, this one, so 0 1 basically. So this have 0 equal to 1 and 1 equal to 1. So I have equal number of 0 and 1. So the maximum length for this equal to 2. Okay, I can take one more subarray from here also. I can take this also 1 0. So this is also giving me of a length of 2. Okay. Now, if can I take this whole array? So if I take this whole big array, this sub array, so this will be 0 1 0. So this having 0 equal to 2 and 1 equal to 1. So you can see we have not equal 0 and 1, so this we can't take it. So the maximum length for this uh, array is basically 2. Okay, so we just need to return this array. So how we can approach for this question is, if I go with the basically name approach, first we can just do basically create all the subarray of that array. So for like how can I create it? So I can just take the two loops over that and just check whether this having equal number of 0 and equal number of 1. So for this generating subarray, basically generating subarray, I cause a complexity of basically n square. So if you can see in the constraint, it's 10 to the power 5. So I can't go with this approach. So I have to optimize it. So if you can see in the question, the array that we are having is binary. Okay. So binary means it's only have two element, 1 or 0. Okay. So can we use this to optimize our approach? So if you can see, the question is already telling us in the sub array, the number of 0 is equal to number of 1. Okay. So that means 0 minus 1 is equal to 0. Okay. So what we can understand by this is, so let's explain with an example. What I will do, I will calculate the sum of this array, basically the prefix sum. Okay. And I will represent everyone with 1, and wherever I come with 0, I will represent it with -1. Okay. So what I will do, I will calculate the prefix sum, and prefix sum start with 0. So I will start from here. I will see first 1 come. Okay, so what I will do, I will just do sum plus this element. If it is 1, represent it as 1. If it is 0, represent it as -1. Okay, so for this it will be 1. Okay, now I can again see it's 1. So what I will do, prefix sum is right now is 1. So I will update it to 1 plus 1, which is equal to 2. Okay, now what we can also do, so now 0 is coming. So for 0, we will represent it as -1. Okay, now -1. So what we will do, 2 minus 1, it will be 1. Similarly, what we will do is basically start with this. Now 0 come, 0 will also represent as -1, so it will become 0. Now this 1 come. Okay, so it will be increment by 1. So this will be 1. Now this 1 comes, so this will increment by 1 plus 1 is 2. Now again 0 comes, so 0 will represent -1, so we will do -2 minus 1, which is 1. Now 1 will come, so I will just write as 2. Now if you can see again 1 comes, so I will do 2 plus 1, 3. Okay. Now what our question is already telling us, like 0 is equal to 1 for our subarray. Okay. So if you can see here, if we found 0th in the element, okay, so 0 in this sum. So if we found 0, that means from the start index, we get all zeros and 1 that is present in the subarray. That's why it's giving the sum as 0. Okay. Now this will be this first condition. Okay. We need to check. If sum is 0, okay. If sum is 0, that means it is already in, like, it's already giving the equal number of 1 and 0, so we can take this as maximum subarray. Okay. So our second condition, what we need to check is basically if you can see this sum 2, and again we are getting this sum. So why we are getting this sum? Basically, the element that are between these sum, they are not contributing to make a sum greater or less than the previous value. So that means they have the equal number of 0 and 1 in between. That's why I get that sum again. So for this, I need to store this sum in somewhere. So I need some data structure which can give me the basically this sum is already present in a map or in an area. So I need some source of data structure. So what we can use a hash map. Okay. So by hash map, I can see if this element is already present in the sum. So I can get the difference between the length of them, and I can take the subarray in consideration of maximum length also. So let's understand with an example. Okay, so when we calculating the sum, we need one data structure that I already mentioned. We need a hash map. Okay, so we will take a hash map, and hash map will be of a type of integer, and it will be storing basically a sum and the index. Okay, so my key will be sum and index will be value. Okay. So let's debug this approach. So what I will do, I will start with my sum as 0. I will see 1 is coming, so I will add in to my sum, so it will become 1. Okay, so I will check first I need to check whether this sum is 0. If it is 0, I can directly take this length from the initial, but this is not 0. So I need to check in my map whether this one is already present or not. If it is already present, then I can take the difference between this index and the previous one index. So right now map is also not present, so we will add it 1 and index value as 0. Now this 1 will come, so our sum will become 2. Now I again check whether it is 0. No, this is not 0. And also I will check in the map. Is it present in the map? No, it is not present in the map. So what we will do, we will insert this in the map and also the index. Okay. Now again, now 0 will come. Okay. And for 0, as I already told you, this will represent at -1. So what we will do, equal 2 minus 1 equal to 1. So as you can see, 1 is already present. I will first check basically, is it 0? No, it is not 0. So, and I will check in the map whether it is present or not. So as you can see, 1 is already present. So what I will do, so my maximum variable is also there. So max equal to 0. So I will check, is it greater than my max? So max difference between this sum, basically the current index minus map dot get this sum. So if it is greater than this max, I will update it. So if you can see, the max equal to 0 and this index right now is 2 minus, and in map dot get I will get as index as 0. Okay, so from this I can get a maximum value as 2. So I will update my max to 2. Again I encounter a 0, so this 0 will represent by 1, sorry, -1. So 1 minus 1 equal to 0. So first I need to check whether this is 0 right now. So this is 0. So whenever there is 0, we directly take so we directly take that index. So we will do max equal to, max for this case is basically max and it will be I plus 1. So I plus 1 is basically because I take the index from 0. Okay. So if you can see, the max right now is 2 and I plus 1 is 3 plus 1, which is 4. So now our max will update to 4. Okay. Now we'll go to this one. So what we will do basically 0 plus 1 equal to 1. So if you can see 1 and we check the condition, is it 0? No, it is not 0. So we'll check in the map, is it present? Yes, it is present. So we again take this approach, and from this we get our maximum by again as right now it is 4, and this will be ith is right now is 4 minus 0. So max remains same as 4. Okay. So if I can show you what's the subarray for this, it will be this. So that's why we are having a length of 4. Similarly, we go for all the process, all the array, and we will found the maximum length of this subarray. So let's write the code for this, and let's take a length in a variable. And we need a map also. Hash map. We will need a sum variable also. We need a sum variable also, and we will do it for int. Basically, let's do x. Let's go with the I 0, I less than n, I plus plus. Okay. So we need to add the sum into our sum variable. So what we will do, sum plus equal to nums I, and we need to check whether this nums I is it 0. If it is 0, then represent it as -1. Otherwise, represent it as 1. Okay. So this sum will update it. Now we need to check two conditions. First is sum is 0. Okay. So if sum equal to 0, we need to do something. Else we need to do something. Okay. So if sum is 0, it's pretty simple. We get the bigger length from the start. So what we will do, we will update our max equal to math dot max sum, not sum, we will just do max I minus or I plus 1. Okay. And if it is not 0, that means we need to check if map dot contains key. This sum is present in map or not. So if it is present, that means this sum is already come earlier also. So what we will do, max equal to math dot max, and we do max and I minus map dot get that index. Okay. Else let's say this is not present in our hash map. So what we will do, we just insert it into that our hash map dot put this sum and pass the index of that current value, and we just return our maximum variable. Okay. Let's see. Let's run the code. So our basic test case is passed. Let's submit the code. So as you can see, our code is submitted. Thank you for watching my video. Hope you like it.